A common question among students is, Mrs. Snipes, what do I need to memorize? And I try to kind of put arrows of things you need to memorize, like within the metric system or kind of exact relationships. And this is another thing you need to memorize, that the density for water, and a lot of times if we want to say the rho or the density for water, we'll put water as a subscript. Notice this is specific because the density of water, liquid water, will change, and this is at 4 degrees Celsius. Of course, what temperature does water freeze at? Well, it freezes at 0 degrees Celsius, so it's still liquid. We're going to go with 3 sig figs, 1.00 grams per milliliter. Grams per milliliter. Okay. Now, so if you want to picture a cute little milliliter, or if you want to picture a cute little centimeter cubed, a cubic centimeter, remember, 1 milliliter is equal to 1 cubic centimeter, so we could also say this. The density of water is 1.00 grams for 1 cubic centimeter at 4 degrees Celsius. So you need to memorize that. That's my point. So speaking of water, and I kind of mentioned that water fluffs out when it transitions from a liquid to a solid. Okay, the transition temperature for water to freeze at under normal atmospheric pressures is 0 Celsius. So that's what we have right here. This, and then we have temperatures getting colder as you're going from right back to left. Yeah, it's getting colder. Okay, so here we have water as a liquid, and here we have water as a solid. That probably makes sense, right? So notice that I'm going to kind of draw your attention to water getting colder as it's a liquid. So let's just look at this segment right here. So water's getting colder, colder, colder. What's it doing? Well, its density, oh, by the way, I didn't mention that's along the y-axis. We have high density up here, okay? So notice that as it's going from, what do they have, about 10? From 10 degrees Celsius to 4 degrees Celsius or so, it's getting more dense. And to me, you can kind of see that as it cools down, the cute little water molecules kind of squish together, and so now they occupy less space and the density increases. Well, here about 4 degrees, it's kind of preparing to transition. As it's getting colder, I kind of think of it that way. Of course, it's going to go from a liquid to water at 0 degrees Celsius. But from 4 to 0 degrees Celsius, check out what happens. Okay, to 0 degrees Celsius. Notice that this is this segment right here. What happens to density? Density decreases. Okay, density decreases. Well, what does that mean? It means it's kind of, the volume is swelling. It's getting fluffier. Now, when it freezes, right at 0 degrees Celsius, check this out. Look what the density dips. Okay, it just does a crazy sort of just swelling. Okay, and actually, this sort of getting larger right here, the volume increasing right here from it going from a liquid to a solid, has to do with the way it's forming an awesome crystalline structure. So if you've ever marveled at snow, you can kind of see a little bit of what water ice crystals can do. So this is volume increases. Okay, volume V increases quickly when it transitions from liquid to solid. Then here again we have it staying as a solid, and we have the solid cooling down. Notice what happens as the solid cools down. Well, the density increases again. So that kind of makes sense. So we have this kind of awesome thing, and it's weird that actually solid is less dense, for water anyway, not most substances, and liquid is more dense. And so actually this is really important for our whole lives. The fact that solid is less dense than liquid, water, that means like ice will float, and that is not any small thing. The fact that ice floats, actually, if you think of the polar regions of the Earth, think of how much water we have tied up as glacier ice. If it didn't float and it sank, that would be a bad thing. So that's all about the density of water when it's liquid and solid state. Now this is just density in general. These are trying to kind of show you that this volume is very similar to this volume. So we have very similar volumes, and density is a ratio of mass to volume. So if the volumes are the same, what's different? Well, you would tell me that this mass is significantly greater than this mass. So actually, that means it's a bigger number here. When you divide it out, you get a larger density. So this is more dense. And you would tell me that just looking at it, but we can kind of see that mathematically if we think it through. So here's what we can kind of infer densities too. If things are allowed to interact, I guess I want to do that. If things are allowed to interact, as we have three things here, we have water, and we have a rock, and we have styrofoam. Usually people would say, well, the styrofoam's less dense because it's floating, and that is totally true. And what's most dense? Well, the rock is most dense because it sank. And so that's that kind of common sense thing we have about density. And then last but not least for this section, I've got a table of densities here. These all happen to be in units of grams of material per cubic centimeter. Remember that a centimeter cubed and cubic centimeter is the same thing as a milliliter. So actually, I don't mean to throw you off, and you probably need to show how this would be, but these units, if you were talking about grams per milliliter, it would be the same number. Anyway, we have it in increasing density going down, which is kind of nice, and these are kind of intuitive, right? Oftentimes when we call something water, we're talking about water in its liquid state, and ice, of course, is in its solid state. So it's kind of interesting. Notice these last down here, these are all what? Hopefully you would tell me, starts with the letter E. That's right, these are all elements. And you can kind of see that elements are not created equal with regard to density. So platinum is very dense. And the next slide, I believe, is an assignment slide.